It all started one shiny day when I came across an ancient book called The Commercial and Political Atlas by William Playfair, published in 1786. In this book, Playfair used for the first time some of the graphs we know today, like line graph, bar graph, column graph, and bubble graph. That night, William Playfair appeared to me in a dream, and he looked very angry. What you make today is nothing like the graphs I meant. I was scared. So what did you mean? I asked him. Exactly what I wrote in the atlas. Have a look. He told me and started writing and drawing. Suppose the money a person received by a man in trade were all in coins, and for 5 days he made a single pile of all the coins received during the day. Each pile would represent a day, and its height would be proportioned to the receipt of the day. A graph is those piles of coins represented on paper on a small scale. So simple, I thought to myself when I woke up. In essence, the format of piles of coins in reality represents in a graph as the visual representation of this reality in the same format. And this is the concept behind the term data visualization. Data are reality, and the word visualization is derived from visual representation of the same format. I ran to check all the existing graphs, and to my surprise, I found that most of them are not a visual representation of the reality they represent. For 5 years, I have read most of the data visualization research. After that, I moved on to research in communication, linguistics, art, graphic design, psychology, statistics, and even literature. And I understood where and when we got lost. Instead of following William Playfair's user's manual that says that data visualization is a representation of reality, each of the research areas explores data visualization only from its own point of view. Statistics do data analysis by data visualization. Psychology explores the perception of data visualization. Graphic design, visibility of visualization. Linguistics, interpretation of visualization. Communication, using visualization. Art, aesthetics of visualization. Computer science, visualization programming only. And everyone lacks the basic understanding of what data visualization is. I returned to the starting point and began to recalculate the route. I started with the definition of data visualization. According to the definition of Stephen Few, who has been nicknamed as the Moses of data visualization, data visualization is a collection of methods that use visual representations to explore, make sense of, and communicate data. And many experts agree that this is the best definition exists today. But we still lack a clear definition of the essence and function of each of the components of this definition. What is the exact definition of data, data exploring, making sense of data, data communicating, and data visual representation? Let's try to define them together. We will start with defining what is data. There are two words, 5 and coins. Which of these words do you think stands for a data point? Raise your hand if you think 5 is a data point. Raise your hand if you think coins are a data point. Raise your hand if you think none of them is a data point. The rest of you are right. 5 is just a quantity value. Coins are just some things that exist in reality. For this reason, we cannot visualize any of them separately. We will definitely ask, 5 of what? Or how many coins? Only when we join the two words together, the quantity value 5 and the things being measured, coins, we can visualize 5 coins and they become a data point. Well, 5 coins is a data point that is easy to visualize. And what does the data point $5 million look like? This is where the difficulties begin. Usually, the first thing that comes to mind is a numeric data record. But we still must not forget that $5 million is not just an abstract record. These are things that exist in reality, like 5 coins. And if we put in a little effort, we can visualize them and then consider them to be a data point. So we can clarify the first component of the definition. Data point is any object or phenomenon that was measured, or in short, any measured thing. Have you ever wondered why we don't use the term data point in the singular, but almost always in plural data? Because a single data point is meaningful only when we compare it to another data point. There are 3 types of comparisons. Comparison is one data point similar to or different from the other one. Comparison is one data point larger or smaller from the other one. Comparison, how much larger or how much smaller is one data point than the other one. And we're not interested in the data itself, but in the relationships between them. Therefore, when we talk about exploring, making sense of, and communicating of data, we mean exploring, making sense, and communicating of the relationships between data, or, as we define them, measured things. Let's move on to the next component, exploring data relationships. Let's return to the data William Playfair talked about. Our data are the coins that the merchant received in 5 days. Will the merchant be able to analyze the coins' relationships if they're placed this way? Will he succeed to determine which pile is larger, which is smaller, and by how much? The answer is no. To analyze the coins' relationships, a merchant has to arrange cards with the names of the 5 days in a line, in order, on the table. Aggregate the coins of each day in a column. Place columns next to the cards in a sequence of days. And measure the number of coins in columns. This means that to analyze data relationship, the data needs to be transferred from disorganized format to organized format that will allow to the human brain to understand their relationships. Thus, the component data relationships exploring can be clarified as organizing measured things in a format adapted to the human brain. Moving on to the next component, making sense of data relationships. What can the merchant understand from analyzing his data relationships? Where in the sequence of days of the week there are more or less coins, and by how much? At the beginning, at the middle, or at the end? And if the merchant organizes the coins in a different format, will he understand the same things as in the previous one? No. By organizing coins in this format, he can easily understand how the piles are ranked from largest to smallest, and on which day he received the most coins, and on which day the least. And if he wants to understand what is the part of the coins he received on the first day within the total number of coins he received during the week, he will have to separate them to see whole and part of the first day in it. So the merchant has the same coins organized in 3 different formats, and from each one of them he derives different meaning. The difference between these formats allows the merchant to recognize different meanings in different formats. Thus, the component making sense of data relationships can be clarified as recognizing of meaning in the format of measured things. Next component, communicating data relationships. The merchant imagines a certain format of coins and wants to describe it to his boss in a way that he will recognize the exact same meaning as the merchant. If the merchant will describe to the boss in words, on the first day I received 4 coins. On the second day I received 4 coins. On the third day I received 5 coins. On the fourth day I received 3 coins. On the fifth day I received 2 coins. Can a merchant be sure that his boss will understand him for sure? No. Words can't communicate data relationships. The merchant need to find a way to describe to his boss the format and the meaning as he has it in his own mind, so that the boss will understand him for sure. Thus, it can be said that communicating data relationship is describing the meaning in the format of measured things. Now, for the last component, the visual representation of data relationships. Do you think that a visual representation of the coins by days of the week as a sliced circle will lead the boss to the recognition of the meaning? Where in the sequence of days of the week are there more or less coins, and by how much? Not really. That is the time to recall what William Playfair explained to us. We called the data visualization this way because the format of the coins in reality is represented in the graph in the same format. And when the merchant will represent the order of the number of coins in a sequence of 5 days and will add a title that describes in word what is described in the representation, the manager will understand for sure and will be the happiest person. Thus, the component visual representation of data relationships can be clarified as visual representation of the format of measured things. We have completed clarifying each of the 5 components of Stephen Few's original definition of data visualization. Data visualization is a method of using visual representations of the formats of measured things adapted to the human brain to recognize and describe their meaning. Don't panic. This is not a definition to be remembered and declaimed. For us, this is a kind of a checklist that allows us to make sure that our visualization is correct and meets all the components. We must check that we have visual representations, not just abstract images, but those that visualize the data in reality. The formats of measured things, the formats of things that have a size we have measured and which we call data, adapted to the human brain, that the human brain understands these formats in a minimum time. Recognition of meaning. Representations allows us to recognize exactly the meaning that we had in mind. And description. And that these representations accurately describe this meaning. But are recognition and describing of meaning the real goal of data visualization? Let's ask our merchant. Does he think, I want to organize, recognize, and describe the meaning in the format of coins I received in 5 days? Probably not. He will think, why did I get less at the beginning and at the end of the week? The goal of the merchant is to get a lot of money for his trading every day. To improve reality. That's what he's really interested in. The organizing, recognizing, and describing the meaning of the format are only the means to achieve the goal. The goal of organizing and visualizing data in a specific format is to help us decide how to change the meaning of this format to a better one, to improve reality, and that means we must make sure that the data visualization we do really contributes to the improvement of reality, because if it doesn't, there's no reason in doing it. So, Our definition is: data visualization is a method of using visual representations of the formats of measured things adapted to the human brain with the goal to improve reality. And I sign under this definition. And by this definition, to improve the sales situation, I will have to imagine it and visualize it in a graph in such a way that my manager will recognize the exact same meaning as me, and we will both decide how to improve the sales situation. Sounds so simple. So, why is it not? Due to 3 reasons. We are unable to imagine data formats that is not in front of our eyes. We weren't taught to describe the meaning in the data format in words. We weren't taught to describe the meaning in the data format in pictures. That's why no one understands us. After all, when we start working with data, what we usually see in front of us is a table of data from which we are unable to recognize the meaning of their format, so it is hard for us to visualize it, because we forgot to think the right way. You probably heard about the theory of the 2 hemispheres of the brain, the right and the left. The left brain is responsible for the verbal thinking. The right brain is responsible for visual one. This theory turned out to be incorrect, but managed to cause many problems. In fact, the brain does not process information separately with words and with pictures. The brain processes words and pictures at the same time. The problem is that after we've been taught for years that visual thinking and verbal thinking are not equal, and words are more important than pictures, we don't know how to use this ability. We only use half of our thinking, utilizing only half of our brains. And to overcome our inability to visualize the form of the data directly in a graph, we will use a workaround. We will learn to use our developed verbal thinking, verbalization, to develop our visual thinking, graphication, for recognizing and describing the meaning in the format of our data. And so, we will fully restore our thinking ability. And William Playfair, he sent his blessing, in my dream, of course. So, graphication, how does it work? There are only 2 rules in graphication. Rule number 1, turn the reality into words and images. Rule number 2, use the data relationships description model. Let's start with the first rule. Let's recall the steps that the merchant took in reality to recognize the meaning in the format of coins in a sequence of 5 days, and will describe them in words. He made the ordering of the cards in a row on the table, placed columns with the number of coins next to the cards in a sequence of 5 days. The verbal description we received consists of 3 components: the ordering of the number of coins in a sequence of 5 days. Our next step is to draw an image for each component. We will draw an image for the ordering. We will draw an image for the number of coins. And we will draw an image for a sequence of 5 days. We will join the words into a sentence and the images in a graph. Thus, we will get the verbal and the graphical description of the ordering of the number of coins in a sequence of 5 days. And we will recognize the seriality, which will allow us to understand where in the sequence of days there are more or less coins, and by how much. And if I want to recognize the meaning in the ranking of salary sizes of 5 employees in reality, and to describe it in words, I will ranking the packages by the salary size and put the cards with the names of 5 employees next to them. The verbal description that I will get also comprised of 3 components: the ranking of the salary size of 5 employees. What is the next step that I need to take? Right, to draw an image for each component. I will draw an image for the ranking. I will draw an image for the salary sizes. And I will draw an image for the names of 5 employees. I will join the words into a sentence and the images into a graph. Thus, I will get a verbal and a graphical description of the ranking of the salary size of 5 employees. And which meaning will I recognize? The hierarchy that will allow me to understand which one of these employees got the highest salary size and which one got the lowest. Now I can present the description to my boss and to be sure that he will clearly understand the hierarchy in the ranking of salary sizes of 5 employees. Sometimes the graph allows us to recognize the meaning even better than we could recognize in reality. Let's look at an example. Let's say that I want to recognize the meaning in changing of sales volumes across a period of 5 months and to describe it verbally. What do I have to do in reality so I can do that? To arrange cards on the table for a period of 5 months, to place the columns with the records of the sales volumes next to the cards, and to imagine the line between the tops of the columns, as I don't have a way to actually create this line in reality. Now, I will write the words that describe the reality I created. The changing in the sales volume in a period of 5 months. And here too, I will draw images correlated to the words. An image for changing, an image to the top point of the columns with the sales volumes record, as I'm not interested in the columns themselves, and an image for a period of 5 months. And I will join the words into a sentence and the images into a graph. And this way, I will get the verbal and the graphical description of the changing in the sales volumes in a period of 5 months. And I will be able to identify the trend in this changing. And when I'll present the description to my boss, I'll be sure that he will exactly understand what is the trend in the changing in sales volumes in a period of 5 months. So, as you probably already understood, we have two main things to learn: which words to use and into which images to translate them. The good news are that in Graphication, there are only 22 types of words and images with very simple syntax rule that create the 5 data relationship description model, and any type of data relationships can be described using that model. 5DRD model. Why 5? The model consists of 5 components that answers 5 WH questions of information gathering. A metric describes what we measure. A space describes where we measure. A time describes when we measure. A format describes how we organize the data. And a meaning that describes which meaning we recognize in the format. They're joined together in a specific manner and create the 5 types of data relationships description. In images, metric, space, time, format, meaning. And in the words, meaning in format of metric, in space, and time. 3 components, metric, space, and time, are defined in a data collection phase. The 4th component, format, is defined in the data organization phase. And the 5th component, meaning, is defined at the data relationship recognition phase. Each component has number of types: 5 types of measure, sum, percentage, difference, calculation, and function. 5 types of spaces: list, logic sequence, total, timeline, and map. 2 types of time: points in time and period. 5 types of format: ranking, ordering, separating, changing, and placing. 5 types of meaning: hierarchy, seriality, dominance, trend, and density. And they joined together. In the data relationship description phase, to 5 types of description: hierarchy in the ranking of metric in a list at a point in time, seriality in the ordering of a metric in a logical sequence at a point in time, dominance in a separating of a metric in total at a point in time, trend in a changing of a metric on a timeline in a period, and density in the placing of a metric on a map at a point in time. These are all the types of description of data relationships exist in our world. Why are these the types? How are they being defined? How do they look like? And how do they join together into descriptions? You'll be able to find all this in a book coming soon, Graphication, a guide to data relationship description. Everything you've seen and heard so far are the first 2 chapters of the book. The book includes all the explanations, plenty of example, and quite a lot of exercises. The book was created together with the members of the data visualization community in Israel, in which I shared part of the book while I wrote them and asked for feedbacks. Following the honest responses, the corrections, and the recommendations on the content and design, today the book looks entirely different than it was at the beginning. Well, friends, I was Bella Graff, the Graphication teacher. You can send all your questions to me by email or to find me and my posts in Facebook and in LinkedIn. And I wish us the best of luck.